folks, on to section 4.2, problem number 72. It says we have the sum of two numbers is 15. One number is 3 less than the other. Find the numbers. Okay, so we're just not going to know how to use x and y and solve for them. They just want us to do that approach using two variables. So I started this problem, and then I messed up, so I restarted the video. Okay. The sum of two numbers is 15. X plus y is 15. Okay. We got x, we got y. Those are the two numbers. One number is 3 less than the other. So you got one number and then the other, and one is 3 less. So you could technically put the minus 3 on either side. We'll just put it there. So one number is 3 less than the other. Find the numbers. So remember I was talking about the substitution method is sometimes easier. You see how the substitution method will be pretty easy right now? So instead of x, I'm just going to put this y minus 3. So y minus 3 plus the y is equal to the 15. So that's a y and a y on the same side. That's a 2y minus 3 is equal to 15. Add 3 to both sides. So a 2y equals 18. Divide by 2, divide by 2. So y is equal to 9. So if y is 9, x must be, two numbers add up to 15. So x must be 6. One number is 3 less than the other. Yep, that's true. Cool. So what are the numbers? 6 and 9. So you probably write it up like that. Ta-da! Okay. Not bad. Let us try 80. So the difficult part about word problems is I should probably try them before I start recording. So if I struggle, don't get angry. 80. Maxim has been offered positions for two companies. The first car company pays a salary of $10,000 plus a commission for every 1,000 cars sold. The second pays $20,000 plus a commission of $500 for each car sold. How many would be needed sold? Okay, so basically, he gets a commission. So there's two pay schemes: $10,000 flat fee and $1,000 per car, or $20,000 flat fee and then $500 per car sold. Okay, so they want us to use x and y. How many cars we need to make the total pay be the same? Okay. Sometimes when you read a problem, you're like, well, how do I even use two variables? It might just be one. So it looks like it's going to be $10,000 plus, and then $1,000 for every X cars he sells. And then the other scenario is $20,000 plus a commission of $500 for each car sold. So plus $500 for every car sold. How many cars would need to be sold to make the total pay the same? What the? I feel like that should be an X also. Number of cars sold. Okay. So maybe there is no Y? That's weird. Okay. Let me just quickly take a peek up top if they do an example like that. And, oh, okay. So, I see what they did. So basically, we can just set these equal to each other, because what they're saying is your, number 80, your commission, your income, let's call it your income. Any variable would have worked. Let's just say Y. The amount of money you make that year, Y, is equal to either $10,000 plus $1,000 for every car sold, or your income Y is equal to the $20,000 base plus $500 for every car sold. So you see how I struggled to set things up, but I looked at an example previously in the setup for 4.2, and it's all making sense. And so if Y is equal to this and Y is equal to this, then wouldn't they be equal to each other? So we could just set the 10,000 plus 1,000 X equal to the 20,000 plus 500 X. Okay, so bring all the X's on one side, minus 500X, minus 500X. So if all the X's are on this side, let's bring all the numbers to the right, so let's minus 10,000, minus 10,000. So that's going to give us 500x, bye-bye, bye-bye, equals 10,000, divide by 500, divide by 500. Pen sort of dying. X is equal to 10,000 divided by 500, which I could probably do in my head, except it's late. 10,000 divided by 500 is equal to 20. I knew that. 20. So, how many cars would need to be sold? 20 cars, right? Because I guess I should have said X is equal to the number of cars. Number of cars sold. Okay. Whew. Do they get more complicated? Let's try 96. Should we do one before that? Number 90? Fine, we'll try 90. 90. Shirts and sweaters. 3 shirts and 2 sweaters for 114. 2 shirts and 4 sweaters. I'm going to call them T-shirts and sweaters. T for T-shirt, S for sweater. S looks like a 5. Sweaters will be X. T for T-shirts. Okay, so in problem number 90, you could buy 3 T-shirts. Make a nice T, lowercase t. 3 T-shirts plus 2 sweaters for 114 bucks, or 2 T-shirts and 4 sweaters, X, for 164 bucks. So how much does a T-shirt cost? How much does an X sweater cost? Oh, this looks just like elimination method that we were doing before. Okay, so you have to read the problem and you set up 2 equations. Now we're back on familiar grounds. Should we get rid of the X's or should we get rid of the T's? So right now you're probably saying, I don't know, let's just multiply the top by 2 and the bottom by -3 and get rid of the T's. That will work. Do that. I want to save 5 seconds, and I'm like, oh wait, 2 goes into 4. So if I just multiply this top line by -2, that'll create a -4x, which will cancel with that, and I will save myself 10 seconds. So I'm going to rewrite it below this line because I'm not messing with it. So -2 times 3, that's a -6t. -2, -2, -4x. -2 times 114. Double everything, -2 to 8. So now I'm going to combine these 2 lines. You see how those go bye-bye? 2t and a -6t is a -4t, equal to 164 and a -228. Have to use a calculator, sadly. That's going to give me -64. Divide both sides by -4, and t is equal to 16. So a T-shirt costs 16 bucks. So T-shirt costs $16. And so a sweatshirt, well, do you want to use this line or this line? Either one will work. We know that 3 T-shirts, but T-shirts are, so I'm going to use this line. A T-shirt is 16 bucks. Plus 2 sweaters, X, equals $114. Okay. So now, let's see. So 3 times 16 is 48. Plus 2x equals 114. Subtract 48. Subtract 48. 2x is equal to 114 minus 48. And the calculator is 66. Divide by 2. Divide by 2. X is 33. So a sweater must cost $33. So right there. T-shirt, 16. Sweater, 33. Whew. Okay. Let's try 96. Probably get a new pen in a second. 96 says, 96, what does it say? The difference of two complementary, like the word complete, complementary angles add to 90 degrees. Angles that add up to 180 are called supplementary. So supplementary add to 180, complementary add to 90. The difference of two complementary angles is 55. So if they add to 90, that means x plus y must equal 90 degrees. If they're complementary angles, they add to 90. X plus y is 90. Okay. The difference of two complementary angles is 55. So x minus y difference must be 55. Find the angles. Okay. So, elimination method. You see that positive y sitting on top of a minus y? That's awesome because they're just going to cancel. So when I combine the two lines together, bye-bye. X and x, 2x, 90 and 55. Oh God, what is that? 9, 5, 1, 4, 5. Did I do this right? I see that it's not going to go in perfectly. Complementary angles add to 90. The difference of two complementary angles is 55. Okay. So, divide by 2, divide by 2. So x is equal to 145 divided by 2 is 72.5. 72.5. So the other angle, so if x is 72.5, and they need to add up to 90, so let's just write x plus y is 90, but x is 72.5, plus y equals 90. Subtract 72.5 from both sides, and so y must be 17.5. Okay, so if I add those two together, they give me 90 because they are complementary. And if I subtract them, it should give me 55. I'm just going to double check that. 72.5 minus 17.5 equals 55. Okay, so these are the two angles. Maybe a little degree symbol. Degree symbol. Whew. Okay, so that one worked out. Okay, uniform motion. Let us try 112. 112. Sarah left Minneapolis heading east. Spells out we, north, south. Sarah left Minneapolis heading east at 60 miles per hour. 60 miles per hour is Sarah. Her sister followed her on the same route, leaving 2 hours later and driving at a rate of 70. Sister, 70 miles per hour, 2 hours later. Okay. How long will it take Sarah's sister to catch up to Sarah? Okay. So we know that distance equals rate times time. Again, I should probably prepare before I hit the record button, but that just wouldn't be my style, right? Okay. So let's set up our little table like we always do. We have our rate times time equals distance that we're familiar with. And then the rate, so we have Sarah, right? Sarah's going 60 miles per hour. Sister's going 70 miles per hour. And then the time, I guess we could just say, the way the book says, like, okay, let's just let that be X, because we don't know how long Sarah was on the road for. Right, this is Sarah, sister. And sister was on the road for time Y. Now, in terms of, so we have time. So here's the tricky part. It says in 112 that Sarah left Minneapolis heading east on the interstate. Her sister followed her on the same route, leaving 2 hours later. 2 hours later. 2 hours later. So maybe, so it'd be like, maybe like, just for example, like 10 hours on the road for Sarah, 8 for the sister, right? Because she was on the road for 2 hours less. 112. Same road, leaving 2 hours later. So if Sarah's on the road for 10 hours, then sister would be on the road for 8. 10 and 8. So here's the tricky part. In order to make them equal, I'd have to put the -2 on that side. Ponder for a second. So how did I figure that out? I kind of talked myself through it. So Sarah is on the road for 2 hours more. So maybe she's on the road for 10 hours. Just doing this lightly. 10 hours and 8 hours, right? So in order to make this make sense, right, you have the 10 minus 2. Can you even see this? Maybe use pink. So this isn't correct. This is just kind of getting a feel for it. That's a 10. That's an 8. And so if x is 10, 10 minus 2, that's 8. And then the y is 8. So basically the tricky part is, what's the relationship between how long Sarah was on the road and the sister? Because we need to get an equal sign in there. So right here, I'm going to put a because that's going to be tricky. So notice how, in order for me to get this equation, I kind of just put in some test numbers. So the 10's probably not right, and the 8's probably not right. So let me get rid of those. Tricky. Okay. But once we have the table, we know that rate times time is distance. Rate times time is distance. And we know that we need their distances to be the same, so we set those things equal to each other. So 60x must equal 70y. And then now we need to plug this in. So let's use substitution method. So see, yes, substitution method is helpful. So y is this mess. So let me just plug that mess in there. So 60x is equal to 70. And instead of y, I'm going to put x minus 2. So 60x equals 70 distributing minus 140. Let me bring things over here. So bring the 60 over the 140. So it's going to look like 10x is equal to, bring the 140 over, 140 divided by 10, divide by 10. And so x, this got messy. X, what's 140 divided by 10? The zeros cancel, it's just going to give us 14. Okay, so x is 14. And so if x is 14, let's put that right here, 14 hours. And then y is just x minus 2. What's 14 minus 2? 12. So Sarah was on the road for 14 hours. Her sister was on the road for 12 hours. Ta-da! And that wasn't explained very well, but hopefully you bought it. Okay, so the rest of them are just like that. Cool. So I think you should be able to handle 4.2.